Awesome. Okay, first, super happy to present today. Finally, an actual presenter, not just a consumer. I'm going to be presenting the CANSSI NCSC Ferry Delays competition, and I'll explain what all those little acronyms mean in just a moment. But first, I get my hot minute to talk about myself. So I'm in the last year of my stats undergrad at SFU. I currently work as a data scientist at Statistics Canada. I mainly do language processing and text classification. And I'm also looking for spring and summer internships. So if your company is hiring data science interns, I'd love to talk to you. But aside from that, I'll get right into the competition. All right, so the plan for today, first I'm going to go over a competition overview. So I'm going to talk about who hosted it, what all those acronyms mean, kind of just a general overview. Then the bulk of the presentation is going to be spent on kind of a data exploration. The data is pretty easy to understand, and I think it's probably a pretty good idea for everybody to take a good look at it, and everybody can play or go along with the presentation and think of how they might have approached the problem. And then secondly, I'm going to be going over my solution, and then I'll be talking about what didn't work, what did work, and then lastly, a retrospective on the whole competition, a lessons learned kind of scenario, and what were the takeaways. So competition overview. So the competition is predicting ferry delays of BC ferries sailing around Vancouver harbors. So outlined in those blue dots, those are the main routes that we're interested in. In the data, we're not given every single ferry or every single route that BC Ferries operates, but just a subset of them. For this challenge, it's a binary prediction problem. So we're not predicting how delayed the ferries are going to be. We only care if the ferry was delayed. So we don't care if the ferry was delayed by 2 hours or 15 minutes, but just whether or not it was delayed. And for reference, BC Ferries defines a ferry that's delayed if it was departed 15 minutes late. So we also don't care about arrival time. It's just strictly about the departure of the ferry. And just a little piece of information, BC Ferries is actually really, really big. I didn't even realize this, but they're the second biggest ferry operator in the world. I think they have about 30 to 40,000 sailings a year, or I think more than that. I think about 50 to 60,000 sailings a year. So they're really, really big. And our goal is, like I said, to predict whether or not the ferry is going to be delayed. So the competition page. Yeah.
It seems weird to make this a classification problem. So did BC Ferries mention why they chose to just say yes or no versus because it seems like an operations perspective, something that was 6 hours delayed versus 15 minutes delayed.
Yeah.
Seems like a big difference.
Yeah, so I believe Alexi was the one who scraped the data, if I recall. This was initially for some other type of competition. Am I right on that?
Yes.
Yes. Yeah. So. All right, wait for the mic so everybody else can hear.
You asked about BC Ferries making that decision. All the data was organized by CANSSI, so it was not actually BC Ferries' decision. But the reason it was posed as a classification problem was because of possible outliers in the departure times. So if some ferries are delayed by a very large amount, then it could become more. Then the problem would actually become a lot more difficult. So the decision to make it a binary prediction was partially to simplify the data. The competition is, as Matt may continue to explain, it's for undergraduates across Canada to
and graduates.
Yeah.
That's where I lost it.
Yeah, thank you.
Yeah, I would agree though that from an operations perspective, it probably makes more sense to have a ferry that's 10 minutes delayed is probably it's certainly a less bigger of a big deal than a ferry that gets delayed by 2 hours, and it also certainly makes it a little bit more challenging. It would have been nice to see though. They could have made almost like 2 competitions out of it, which would have been pretty neat. But I guess, well, it takes a long time to do 1 competition, so I'd imagine having 2 is a little bit too much. Okay, so as it was pointed out, so the NCSC part of the challenge is the National Case Studies Competition, and it's hosted by the Canadian Statistical Sciences Institute. So every year, or maybe even more frequently than that, or I think more frequently than that, they have a National Case Studies Competition where they get a data set, they formulate a problem, and they pose this challenge to Canadian students. So in this challenge, you had to be a Canadian student to participate. So if you tried to download the data and you wondered why it said invited users only, it's because you had to be a Canadian student in order to participate in the competition. So this is like really like the Little Leagues of Kaggle. Like this was not, we were not like participating with any like grandmaster Kagglers in this one or anything like that. It was much more low level than that. Non-competitors, you apparently couldn't download the data initially. The competition was open, but I think they closed it shortly afterwards. So unfortunately, nobody else could download the data. And I didn't realize that until fairly recently. Otherwise, I would have asked to post the data so that anybody else could use it. As far as I can tell, though, the data is like all public and stuff. So I think I'm allowed to just give everybody the data, but I didn't want to rock the boat. And like all Kaggle competitions, there's prizes associated with this one. And they're just outlined below. This competition, though, is a little bit non-standard. And what I mean by that is this competition, the Kaggle portion of the competition is kind of the first stage in the National Case Studies Competition. So there's a regional level and a national level. So in addition to just the raw predictions that you submit, you also have to provide I think a poster or something like that, and you get judged on your solution. And of course, your score plays a role in it, but also like the way you present it and the way you explain your solution matters quite a bit. And then 2 teams win on the regional level. So, and then I believe 3 teams win at the national level. And the regional level is hosted next week on Friday, and the national level is about a month from now. So winning just the Kaggle portion of the competition does not mean you won the case studies competition or anything like that. There's still a little bit more to it. Oh, we have a question.
So you're assessed on your report quality. Can you just submit this video that's on YouTube as your report?
Yeah, I wish I could. I could just give them the video. It's like, okay, here guys, just skip the first 20 minutes or so. You guys, the background. Just look at the modeling part, and you'll figure it out. But no, as far as I can tell, I still have to make a little poster thing for that. By the way, I still have to do that. The competition, just for reference, it started about a month ago. It ended last night, so I was a little concerned that if I just bombed on the leaderboard or something, I would come here with my last place solution and wonder what went wrong, but ended up working out just right. So I was confident in myself, but just due to some scheduling issues, I could only present this week or a month from now, and I didn't really want to present a month from now. So yeah, this competition is very non-standard. Just for reference, for anybody who's not familiar with Kaggle, this is not what you have to do. Generally, it's just you submit your predictions, and then some competitions require winners to present in some workshop or submit some supplementary things. But this is a very non-standard Kaggle competition for a few reasons, as I mentioned. So so on to the results. So as I alluded to, the competition only ended yesterday. And I did not know if my solution was going to be good or not. I was pretty confident in it, but for all I knew, I could have bombed out in last place or something. There are about 65 teams in the competition. This is the public leaderboard, by the way. And this is what the public leaderboard looked the day of the competition. Yeah. Oh yeah. So on Kaggle, they split when you submit predictions to the public leaderboard. So the score you see is it's about 30% of the data. It's usually a smaller portion of the data, and you can see how well your model performed on that portion of the data, but you don't know how it performed on the majority of the data. And the idea is that if they just had all the data on the public leaderboard, then you could just keep submitting predictions and then choose your model based on how well it performs on test data that you can get the answer to, which would obviously be no good. So that public leaderboard is just kind of like a general place that you're at, but is only assessed on about 30% of the predictions. I don't know if you want to add anything. Is that good? Okay. So this is what the public leaderboard looked like the day before the prediction, before the competition ended. This team up here, I was actually ahead of them until 20 minutes before the competition ended, and then they submitted a solution that went, I think they went from just under where I am on this board to their current score. Yeah.
We have some people from SFU in the room. Do we know who this team is? SFU
I know.
Sports?
Yeah, they're 2 master students.
I think it's Din.
Yeah. Yeah. Two master students, as far as I think they won like the Big Data Bowl last year or something like that. They do a lot of sports analytics. That's why their name is SFU Sports Analytics. So I was a little bummed out like 20 minutes before the competition ended, like 11:40 a.m. or 11:40 p.m. right before it ended. I refreshed the leaderboard while I'm sitting in bed, and I see them. They just jumped. Their score just jumped, and they had been submitting predictions for like a few hours before then. So I was pretty confident, like, okay, I got this. But then they jumped ahead of me at the very end. Unfortunately, I didn't have to wait too long because I was 20 minutes before the competition ended, and this is what the private leaderboard looked like. So I actually went up on score, which is very, very non-standard. So I overfit the private leaderboard like a true professional today. Originally my name was Overfit the Leaderboard, but I thought, let's have some positive energy. Let's overfit the private leaderboard. And, having your score increase from the public to private leaderboard is as good as you're going to get overfitting it. So go me. I ended up coming second. If you actually look at the scores here, the team in first, because that last little change they made, they're pretty far ahead of me. But similarly, it was pretty far ahead of the next team, and then the scores kind of just fall off in around like 0.7 afterwards. And you can actually see how much people dropped, and I have some theories about why some teams end up dropping, but I'll get to that in a little bit. So I ended up coming in second. I feel, I guess, fine about it. I know this team's pretty good, so I didn't feel too bad about it. But that's probably it. And I will add that it was very nerve-wracking. I was convinced. I was convincing myself the whole night. I was like, I've overfit the leaderboard, and my score is going to be terrible the next day. But fortunately, all worked out. I didn't know what I was going to do today if my score went dead last. So.
Did you celebrate, or did you just go to sleep?
No, I went to sleep. I had class the next day, which is today. So I was like, okay, well, it worked out fine. I was pretty happy that I beat the other team. I went up one. Second place is fine by me. So it all went well. So those scores that I was just showing you, so the competition metric is AU ROC or AUC. It's the area under the receiver operator curve. It's pretty simple stats metric. But I thought I may as well explain it to everybody here just so that we're all on the same page. But before you understand what AUC is, you have to understand what a receiver operator characteristic curve is, which is a bit of a weird name. I don't really understand why it's called that, but it sounds a lot more complicated than it is. It's really just a plot of the true positive rate versus the false positive rate of your predictions. So if you remember a model, it will output probabilities, so whether or not the ferry is going to be delayed. And what AUC does is it picks a whole bunch of hypothetical thresholds. So it says, if your predictions are below 0.5, we're going to say the ferry is not going to be delayed. And if it's above 0.5, the ferry is going to be delayed. And it chooses a whole bunch of thresholds, and then it builds this little curve. So if you notice this curve, this blue curve here, it's not smooth at all, and that's because it's not like a continuous metric. That's not very important, but basically and the metric is this shaded blue area. So it's the area under this dark blue receiver operator curve. And if you're familiar, if you want to know what the true positive rate and false positive rate, they're just down here below. But basically just how many, like all binary prediction metrics, it's essentially just how well can you separate the two classes. And like I said, the area under the receiver operator curve is the area shaded in blue. And I was going to ask this, is there any, for binary prediction metrics, I'm sure there are many, is there any reason why you choose AUC over some other metric like log loss or some other metric like that, or F1 or something like that?
F1. Is this on?
Yeah.
Okay, thanks. F1 you could probably use. AUC is another really nice one that it's insensitive to the class balance there.
Yeah. Okay. Well, it's like,
So if you have like cases where, I mean, if 50% of your ferries would get delayed, your business is in trouble, right?
Yeah.
It's likely that you have about a small percentage there, but you want to get rid of all of those.
yeah. Oh, yeah.
I mean, there's the nice theoretical property of the AUC as well, right? I'm pretty aware of. But if I took two random, like a random false, and I took a random positive, and then I sort of compared the score. If I had a continuous score, I compared the scores and from my model, and if it got aligned correctly, then that would be the probability of that being aligned correctly is equal to the AUC. So it has a nice,
Okay.
yeah. But yeah, I guess it addresses that class imbalance problem as well.
Yeah. So I guess it depends on like what your goal is. Like the AOC sounds like a perfectly fine metric. I also want to note that so the worst AOC you can get is 0.5. It basically means you just completely randomly guessed all your predictions. If you get less than 0.5, what that means is actually if you invert your predictions. So if you think like, if 0 was the ferry's gonna be delayed and 1 is the ferry's not gonna be delayed, if you just inverted your predictions, so 1 was your ferry's not gonna be delayed, then you'd get a higher AUC. So 0.5 AUC is the worst you can get. So those 0.7 scores that we were seeing, like I don't really understand, I don't know how to interpret like what a good AUC looks like, but I'd imagine like 0.75 isn't that impressive. But I just thought I'd throw that out there just because like 0.5 is basically the worst AUC you can get. But that's the competition metrics. That's how all the models are assessed. Okay, so the data. So we're given data of about 62,000 sailings between August 2016 and March 2018. And for routes that start or end in one of these four locations, and I'll have a map on the next slide so you can see exactly where those are. But Horseshoe Bay, Schwartz Bay, Tawasin, and Departure Bay. The training data is about 50,000 records from August to November, and the test data is about 12,000 records from December to March. And if you're looking at that, one of the things that sticks out is that the amount of testing data we have, or like first the amount of data we have like over the period of time, we only have about 18 months of data, which when there's a lot of seasonality involved in ferry sailings, is a bit of a concern, or it's a bit of a problem. And the test set is only December to March, which is, if you're familiar with ferry sailings in Vancouver weather, that's really the off season for BC ferries. And as we'll see in a little bit, those months you're much less likely to have a ferry delayed compared to say the summer months. And that is one of the challenges that's with this competition. Yeah.
So is that routes starting and ending?
Yeah.
At one of those four? Okay.
Yeah.
It's not like the huge set of things coming out of Tawasin or anything.
Yeah. So I think it's about 20 routes, but keep in mind a lot of them are round trip. So like Schwartz Bay to Departure Bay, and then just Departure Bay to Schwartz Bay. So I think it's about 12 unique routes that are not just the return trip of the previous trip. And there's another question in the back. But BC Ferries operates many other sailings. Like there's a lot that go, especially further north. They're just not included in our data that we were given.
Hi. I was sort of involved in the previous competition where they had the ferry data and then it also included weather information and traffic information. Did you have that in the competition?
This is that competition, I believe. We have
No, so like the data was previously used for a data viz competition for a math and statistics conference.
Yeah, okay, then it's the exact same data.
Okay, but you still have the ferry data appended with the weather and traffic information.
Yeah, I'll get to that in the next slide, and
Okay.
we'll for everybody else who hasn't seen it before, we'll take a look at the data and we'll have some nice little plots, and then you guys can tell me if there's anything in particular that you want to see. But we'll make sure everybody understands the data because there's not that much of it, and it's not that complicated to work with. It's not like we're working with a bunch of image data or anything like that, which is a little bit more difficult to work with. But it's just like all tabular data.
Okay.
So yeah, the big challenge of this competition is like we're trying to predict like whether a ferry is going to be delayed months and months in advance, which is a bit of a challenge. It depends on I guess what your if this was a real problem, like what your objective would be. But I don't know how interesting it'd be if I can predict now if a ferry in December 2020 is going to be delayed. I don't think that's extremely useful. But we have to predict the ferry delays like months in advance. And one of the issues is like we'll see in the data again, but there's quite a few days where you'll have like a mechanical delay early in the day, which just causes these cascading delays all throughout the day, and it ends up causing like over half the ferries to be delayed. But you can't really forecast a mechanical delay of that magnitude, or at least with the data we were given. So that turns out to be a pretty major challenge, at least. And that's why we didn't get like super high AUC scores or something like that. It's just we just didn't have the data to actually do those kinds of things. So as I don't remember her name, but as somebody said, in addition to the typical training and testing data, we're given some extra data with some covariate information. So we're given 3 CSVs. We're given traffic.csv, vancouver.csv, and victoria.csv. Traffic.csv contains a bunch of traffic data on the Lionsgate Bridge. It's taken every minute, and again, we'll open up the data sets and we'll take a look. We're not given like a traffic volume or anything. We're given like a traffic score almost. It's like an ordinal from 1 to 5, where like 5 is super busy traffic and 1 is not very busy traffic. So we're not even given like, there's 500 cars an hour going on the Lionsgate Bridge right now. We're just given an ordinal. And as we'll see later, it's not a very good predictive power. Like I just completely ignored it. And I think based on what everybody else's scores were, I think everybody else did as well. It's not very good. And then Vancouver.csv and Victoria.csv are weather data. So Vancouver.csv is weather data from Vancouver Harbor, and Victoria.csv is weather data from Victoria. The one weird thing is that Vancouver and Victoria CSVs, they do not contain the same weather data. So Victoria contains wind speed data, which turns out it's the only one we care about. Vancouver does not contain that. It contains things like dew point and temperature, and I don't know if the dew point being 3.8 degrees really makes ferries be more delayed. So didn't even touch any of those things. Really, all we're after in the weather data is just wind speed, but I'll get to that. Here, maybe I'll just hop into the notebook right away. Okay, so I just loaded the data, and we're just going to take a look at the actual data file. So this is traffic.csv. This is what it looks like, or maybe I'll make it even bigger. We're just given a traffic ordinal and then like a date time. Well, not even really a date time, but you can make it a date time. It's pretty useless. I never even touched it, and I don't think any of the other teams did as well. Vancouver is the weather data from the Vancouver Harbor. And again, we're getting things like temperature, dew point, and humidity. None of those things are very useful. So again, this Vancouver.csv is not very useful as well. And then Victoria.csv, this is the only one we actually care about. We're given, in addition to everything that was in the Vancouver data, we're also given the very, very important wind speed.km.hour. So this gives us the wind speed measured at around Victoria. They don't tell us exactly where it is, but it's somewhere around Victoria. And that's what the weather data looks like. And oh yeah, okay. We have a question.
So it's funny that you just blatantly say they're not useful, but I'm guessing you did some exploratory analysis to find out that they weren't useful?
Nope. So the traffic data, I was thinking, well, at best, you're going to, like, at the very best, you're going to fit a lot of noise, but at the very best, you're going to be capturing the fact that, on Fridays, there's lots of traffic, and your model's going to be thinking that, when there's lots of traffic on the bridge, all the sailings are more likely to be delayed or something like that. To a lesser extent, because trees and stuff. But I did not conduct any analysis on any of this data. I was pretty confident. Like, I didn't want to join this table. I was like, it's not even worth the 20 minutes it would be to join this table with everything else. And I was pretty confident in this because nobody else, really. Maybe the team at first used the traffic data, and maybe I was the fool who didn't. But I completely ignored the traffic data, and I'm unashamed to admit it. I was not very confident that I'd be fitting anything of real value, and I just left it out.
Well, what about the weather data?
Oh, so the weather data. So, okay. If I'm going to add, if humidity and like the temperature is like what's going to cause, a ferry to be delayed, I mean, I'm amazed. But I'll get to reasons. Oh yeah, we have more questions coming up too. But I was thinking about it at some point. I just never got around to even trying to touch it. I know it's not very data sciencey of me, but I'll chalk it up to domain knowledge, and we didn't need to explore them, and I saved myself so much time.
So did you test these features, or are you making assumptions that they're not helpful?
I'm making a wild assumption that they're useless.
Oh, interesting. Okay.
And I'll consider myself an authority figure on it because I came second to the competition, so surely it wasn't useful at all. But no,
At the end of this, we're all going to be wishing you did not come in second.
Yeah, well, I mean, frankly, we'll see it a little bit later. There's also a lot of other features. I think there ends up being about 45 or 50 features in the model, and I was a little concerned about just fitting all this noise into all my data, and I was going to stick to the things that were pretty, that I knew that I could be pretty confident in were going to be useful. Don't quote me on this, but I may have looked at temperature or something. I may have looked at temperature data, but I did look at some other things. So I also forgot to mention, so Victoria data also has the actual weather. So you can actually say it's raining or something like that. So I did look at, if it's raining out, our ferry is more likely to be delayed or less likely to be delayed. But I ended up actually using this weather feature in some feature engineering that I'll show a little bit later. It wasn't very useful though. It didn't lead to big performance increases. But what was important here is just the wind speed. That's all I care about. Everything else is kind of useless. And again, I didn't actually check to make sure it's all useless, but I was using the leaderboard as my guide of whether this was useless. If everybody's going way ahead of me, I was like, okay, well that's pretty useful. I may as well take a look. But yeah, so I did not look at it very, very carefully.
Can I maybe pull some of the, so there's other people in the room that also competed in this competition, is that right? Do you guys
Team at the back.
do you have any thoughts on some of these features that he's talking about? Or?
Tell me I'm wrong, please.
Yeah, I actually did analysis on those features, and I didn't find dew point to be useful. I did find temperature to be useful, pressure, and wind speed as well. Wind direction, I didn't find it to be useful at all.
Out of curiosity for the weather or the temperature, did you look at by month? Because obviously in the summer it's a lot hotter, and in the summer there's also more delays. So that's what I was concerned about. I was thinking, well, month is going to capture the fact that it's warmer in the summer. I don't really, it's warmer in the summer and it's warmer in the midday than, December morning or something like that. So I was pretty confident it was useless, or a lot of that information was being captured in other variables.
Well, I compared it against the target, not the months.
Yeah, well, I was thinking maybe
just like the Celsius versus the target.
Okay, so maybe it would have been useful, but I was thinking, if I was booking a ferry this morning, what would cause me to actually knock down that ferry? It's it's too cold out, probably not. But if it's raining a lot, yeah, maybe I don't go to the island that day or something. But maybe I did leave out some stuff. Maybe I had a supermodel, but I just left out some good data. But
well, it's a fair point that if there's another variable that describes it even better, then there might be some correlations between temperature and your target. But I mean, if the month is also more descriptive, then you might have a point.
Yeah,
you did come second, so it's very hard to argue.
And also time of day. I didn't want to start doing this crazy analysis where I was going by month, by time of or by time of day and stuff. I actually. Spoiler, I actually ended up cutting down a lot of my number of features I had, and I was getting better performance with that. So I think I wanted to keep it kind of to a minimum. I didn't want to, I still ended up having 50 features, but after one hung coding. But yeah, the weather data, a lot of that weather data I wasn't very confident in. Yeah, another question. What am I after time?
Did any of the documentation talk about why they included traffic? When it's just so focused on the Lionsgate, that doesn't even go anywhere near Schwartz Bay?
So I think the original plan with this data was actually the opposite, where it was looking at whether or not the ferry impacts bridge traffic. So they reversed the problem. They said, okay, well, I guess maybe in their mind, they were thinking that traffic data would be useful, maybe not. But yeah, that's why it was included. Just I guess for brevity. But yeah, a lot of this data wasn't particularly useful, especially Vancouver.csv. That was the most useless weather file they gave us. I didn't know what the point of that was.
Yeah, because we were talking about the traffic data before, and I looked on the BC Ferries webpage researching this today just to get ready, and then they're saying 58% of the delays were traffic related, and only 3% were weather related. So how would?
Yep, that's the next slide. Okay, well, the question comes, why are ferries delayed? And you can think of 1,000 reasons why, but fortunately, given to us for the training data is the actual reason why the ferry was delayed. So BC Ferries, they give like 20 different ways a ferry can be delayed. But the big ones are so-called traffic delays, operational delays, and most of these other variables are actually ongoing issues because of traffic and operational delays. I'll get into what a traffic delay is, but an operational delay, I still have no idea what it is. From looking at the data, it looks like every time it was a really busy day, they had operational delays. So I assume it's a similar, from the same vein as traffic delays. As was pointed out, the majority of the reason why a ferry is delayed is traffic. Weather-related delays are like 3% of all cancellations. And as you can see, almost all of our data is equipped to deal with that 3%. And aside from some other variables, we don't have that much to tackle the big elephant in the room, which is the 80% of the reason why a ferry is delayed, which is traffic. I also forgot, I did not show anybody what the training data looks like, which is the most important kind of data. So in the training data, they give us the name of the vessel. So it's the vessel that conducted the sailing. It turns out that some ferries are much less reliable than others. We're given the time of departure. We're given the status. Status is only in the training data, but it's either on time or a reason why the ferry was delayed. We're given the trip, the duration of the trip, which is not available in the test data as well. It's also, as far as I can tell, it's not actually how long the ferry took, but just how long that route typically takes, as far as I could tell. We're given the day of the week, the month, the day of the month, the year, then they give us the full date as well, just so we don't have to concatenate them. This is the response variable, delay indicator, which is just binary. The ferry was delayed or it wasn't. I actually made that feature, and all that is just features I made, which we'll get to in a moment. Whoops. And for the wind speed data, this is what the number of delays by wind speed. There's a little bit of noise at the very end, but it looks like somehow some ferries did make it or did manage to conduct their sailings when in 70-kilometer-an-hour winds. So go them. I think I actually looked at that, and there's a particular sailing that is like really, really short, and it's like in a cove. So ostensibly there's no wind around there. But I should actually go back here because I talk about some other stuff, and we'll go back to the data in a moment. So I was wondering, so why does this traffic cause a delay? And it's because that's what BC Ferries defines as a full ferry, like roughly. To me, that doesn't look like a full ferry. That looks like, it's like half empty. But apparently to BC Ferries, that's what a full ferry is. And the idea is that when they have lots of traffic, they'll end up pushing all the cars closer together, and they'll really load up the ferry really well. And I guess the thinking is it's better to be 20 minutes late throughout the day, but get more throughput from the ferries. But what ends up happening is if there's lots of traffic, they end up stuffing the ferry, and it just takes longer as a result, and the ferry ends up being delayed. And I should also mention there's another one that says canceled, which is the little gray one at the very back. That can be for like any reason. So sometimes the ferry gets delayed for like weather-related issues, and they just call it canceled. So the status indicator isn't like incredibly reliable, but it's just kind of for exploratory analysis, not really for, you can't use it for prediction. So the weather data. So one of the things I did was, so as I mentioned, Vancouver.csv sucks. And it's also, Vancouver is over here, and my ferries that I care about are way over here. And Victoria, if you're not familiar with Vancouver, is way down there. So I was thinking, what if it's really windy down here, but it's not it's all calm up here. So what I did was I went and got some other weather data, and it turns out, fortunately, Environment Canada has historic weather data, so you can actually search up weather stations. And I managed to find a bunch of weather stations that were closer to where my ferries are. So I have one from right around here. I have weather data from right around here, and then weather data from Victoria, and then I think I have another one, from Tawasin. Whoops. And by doing that, and then I joined the weather data on the correct route. So I had weather data or like wind speed data from like near where the ferry actually departed, or as close as I could get to it. And if you're actually curious at all, which you're probably not, this is what it looks like. You can actually download the weather station data. You can actually search. You can actually just search for places. So you can enter in a location, say I want all weather stations around this area, and then you can look through various weather stations, and you can actually even specify ranges where you want weather data, because it turns out not all these weather stations record data all the time, and fortunately it didn't end up taking too long to download the weather data. It was maybe half-hour work to get all the weather data all sorted out, but I ended up getting better wind speed data as a result. Yep.
Sorry, you attached the relevant weather data location to where it left, or where?
Yeah, to where it left.
Okay.
Yeah, because for this competition, we only care about departure delays. We don't care about whether arrived on time. Now, there is a point to be made. Well, if it's really windy where the ferry is going to be sailing, well, that might be an issue. And I was like, well, if it is an issue, oh well. Also,
I'm thinking that the ferry arriving might have arrived later than it usually would, and that causes a delay to leave again.
yeah, could have. I did think of it. I didn't really decide to do it. Well, first off, I did notice that the wind speed data was generally pretty good. Like the wind in Victoria was pretty indicative of like the wind around like Victoria, Tsawwassen, and Horseshoe Bay up here. Wind speed data from around there was pretty indicative of what it was around Nanaimo. I was just trying to make my weather data just a little bit more accurate. But yeah, you're absolutely right. Like, if it's really windy where the ferry's going to, well, they might just cancel the sailing as well. But the wind speed from the actual departure location seemed to do pretty well. And I also used some other features that ended up helping, but I'll get into that once I actually go through all the data. So actually, I'm going to hop into the code here because I'm going to hop into the code here. Oh yeah, and so here's some other things that you might be interested in. So portion delays by day of week. So like Fridays and apparently Thursdays. I don't know why. Thursdays are more likely to have delays as well. Portion of delays by month. So like just for reference, the test set data concerns the month of December, month of January, February, and March. So these three, and then this right here. And as we can see, especially in January and February, you're much less likely to have ferry delayed, whereas in the summer months, you're more likely to have ferry delayed. And that ends up actually being a big thing in the competition, is dealing with that. The test data is not a full year data, and it's not indicative of BC ferrying's delays as a whole. Yeah.
Am I reading this right, that in June, 25% of all ferries are delayed?
Yep. By 10 minutes, or at least. Yep.
So just to clarify, I don't know if you already said this, the schedule is the same every day, every month?
Yep.
Okay.
It changes a little bit. They have they'll have like 5 months, same schedule, and then they'll change it for different seasons and things like that. But yeah, I use the time of departure as a feature as well, and the sailing and everything like that. So I do capture that for the most part. But yeah, the ferry schedules do change. So maybe looking at when that change happens, maybe that would have been a neat feature to add. Maybe there's a lot of delays that occur during that time, but oh well, didn't do it. And then delays by hour departure. This is a bit of an outlier over here. I'm not totally sure why that happened. Maybe a ferry got, I did look at it. There's not many ferries that apparently sail at 11 o'clock at night, but the couple that did end up getting delayed, so it looks a little bit skewed here. But yeah, the time of day is, of course, a big indicator of whether or not ferries may be delayed. And then by the route, so Swartz Bay to Fulford Harbor, it's actually in a cove, and that's what I was talking about. There's one where somehow the ferry sailed with 70-kilometer-an-hour winds. I believe it was Swartz Bay to Fulford Harbor because it's actually in a cove. And I looked at that variable, and in no time in our data has it ever been delayed due to weather. So I guess it's in a nice geographic spot. And then this was the last thing I wanted to look at in this little notebook here, was distributions of how many delays occurred like group by day. So like what this tells you is that there was a few days where there's like really catastrophic delays, like 30, 40, 50%. But the majority of the days there's not that many delays. There's less than 10% of ferries are delayed. I also realize that I'm going way too slow, so I'm going to be speeding up a little bit here. Maybe I'll skip a little bit of the code. So validation. So as I mentioned, not all of the months the test set only has a few months worth of data. It doesn't have any of the summer months. It really just has the off season. And unfortunately, in our training data, we only have one example of each of those months because we only have 18 months of data in total. So, and it turns out that you can't just do a simple train test split, especially on time series data, and expect to have your validation set be a really good indicator for how well your model performs. I suspect a lot of the teams that ended up losing a lot of points from the public to private leaderboard, they did not have a good validation strategy, or I heard through the grapevine some didn't at all. They were using the public leaderboard as a validation set. That's no good. But one of the issues of the competition was your validation set scores were not always a very good indicator for whether or not your model is actually any better. And the only reasonable way I could think of, because one of the problems is I can't just use the months in the training set that also are in the test set as just purely a validation set, because then I won't have any examples that when I build the model, I won't have any examples of those months being trained on. So we're working with such a short period of time of data. So what I ended up doing was I just randomly selected 11 days, and here, I'll just show you. I just basically sampled 11 days from each of those months in the training data, and I used that as my validation set. So I ended up getting 44 days of data in my validation set, which isn't that much, but it turned out to be at least a reasonably good way of doing it. So where is it? Oh yeah, so I have my training data. I basically just I pick out 10 random numbers from 30 days, and then what this does is and this is when I'm making the validation data, if the month is January, February, March 2017, or if it's December 2016, and it's in one of the random days I picked, I'm going to use that as my validation data, and everything else I'm going to leave in my training data. And I'm actually very curious if anybody has a much more intelligent way of doing this, because this worked out pretty well for me. But even if you just randomly sample, like if you take 20% of the data from those months, you end up getting really, really optimistic validation set scores, because you get sailing data from like the day that the actual ferry, or that ferry in your validations, or you're training on data about a ferry that departed early in the day, and in your validation set is a ferry from later that day, which is not reflective of the test set. So that was my strategy. I don't know if anybody has a better idea, but it seemed to work reasonably well. No? Okay, that's what I like to see. But yeah, generally what I observed when I tried out this strategy, generally if my validation set scores went up and my test set scores went up, so in a sense I was pretty confident my public leaderboard score was good, because when I submitted that prediction, my public leaderboard scores went up and my validation set scores increased. So I was like, okay, it's good. So that made it a lot easier. I'm actually going to skip this, but I was going to ask, whatever, I'll just ask. So my understanding is, so when you train a model, you split your data, you have train tests, you have a train data, validation data, and you have like your test data. And you build a model in your training data and you predict on the validation data, and you use that validation set score and you say, okay, my model is this good, it's 80% good. And then when you put your model into production, do you retrain your model using your validation data and your your training data and your validation data, or you do just leave the model that you train on your validation data? What I mean is, like, you've used the validation set to say my model is 80% accurate. And you've used it for that, and now you're off to go put into production. You retrain it with all your data.
Yeah, this is actually a good question, and probably something I'm not doing properly. So I usually only split it in two sets, training and testing.
Yeah.
And then I just use the testing to like optimize parameter selection, and then I guess if it's a Kaggle competition, I would just pick my parameters and then I would just train on all of the data and throw it in. Any other? Yeah.
Okay.
So, but there are a lot of people that use 3 sets.
Yeah.
And I think some people are worried about overfitting to your validation set.
Yes. That's what I was very concerned about.
Right? So it's better practice to have 3 sets, and then you optimize for your validation set, and then you just use your test set to say like, yep, still good.
And you only look at it once. Like, from a very
Yeah.
kind of clean perspective, you should only look at the final one once, because that's going to go out of sample error.
Right, okay.
Yeah, you don't want to keep peeking at your test set because then it's not really a test
Because
set
now you're
anymore. It's like
overfitting
a-
to your test set.
Yeah.
So that's like your golden validation.
But then at the end of the day, because all of this is just for parameter selection or for number of epochs you're running in deep learning or something, at the end of the day, you just throw it all in, you throw all of your data at once into the model and train on it. That would probably give you the best. But why don't you just optimize all of your parameters and then train on everything with those parameters?
Then you won't know what the actual out of sample error should look like going forward.
Does anybody agree with me?
I'm sorry, Matt, I agree with Mike's answer. But anyways, at least for my purposes, I noticed that if I retrain my model using all my validation data, my thinking was I'd use my training data or use my validation set to measure how well my model performs, and then I'd retrain my model using my validations, and if my score increased, then I would retrain my model using my training data and my validation data. I'd make a prediction to Leaderboard, and then supposedly I get a better result than if I just used my model that I'd been trained on all my data minus some validation data. At least for my case, I was really weird. I was a little perplexed by it, but I was noticing that my models were performing much, much worse if I retrained them on all my data. So I did not retrain my models. I just trained on only my training data, and I left my validation data alone. But that was just my observation. I think that was just a feature of the data, though, because generally more data is more better, but.
Yeah, were you using early stopping or something?
Yes. So I'll get into it in a moment. Like some models, like this was prior to me using XGBoost, so I wasn't using any models that were actually using the validation set to build the model. But even when I was retraining my models and all the data, I was still getting worse results. But that may have just been a feature of the data. That's definitely not like a general statement or anything like that. I also want to briefly talk about ensembling models. I don't know where we're at for time. Okay, we about 15-ish minutes. Oh, we got a little bit of time. Okay, got 25 minutes. So ensembling models. So it's really, really easy to do. At least a really basic ensemble is like brain dead easy. You basically just average things, or you do a weighted average. And it turns out it's really good. Like you get much better results if you have a bunch of models and you ensemble them all together. But it kind of relies on it, but you have to, when you're ensembling models, each of the models in your ensemble has to give you like different results in a sense. Or, because if you have 3 models and you average them and they give you the exact same predictions every time, well, you're going to get a model that's going to give you the exact same predictions as a single model. And that's just a general thing with ensembles, like, models like random forests sample for each of the trees in the random forest, they sample a subset of the predictors and a subset of the data to get around this issue so you don't end up making 500 decision trees that give you the exact same results. But that's one thing that you have to keep in mind. So you have to kind of use like a bit of a variety of models when you're creating an ensemble. Otherwise, if you create 3 models using the same data, same features, same model, then ensembling them doesn't do anything. So, but for me, I'll get into the next slide, but when I ensemble my models, I ended up getting a pretty nice bump in score. So it ended up working out very well. And I just did a simple averaging. I know there's many, many ways to do this, but for my purposes, I was a little concerned about overfitting the leaderboard, public leaderboard. So I didn't end up, pursuing it too heavily, but I did get a nice bump in performance. So my solution. So I used 3 models in my ensemble. I used XGBoost, I used a random forest, and I used logistic regression. Logistic regression kind of is a little odd there because you think, oh, that sucks. That's a crappy model, or it's a weak model. But no, it ended up, I tried excluding a logistic regression model in my ensemble, and I tried including it, and I got a pretty, I went up about 1.5% if I included the logistic regression. So it was actually a big deal. And I have a theory that it's because, as I mentioned earlier, that training data is months in the off season, and I was looking at roughly what the predictions were that the logistic regression was giving me, and they were generally giving me lower probabilities that the ferry's gonna be delayed for all the predictions. So what I suspect was going on is it was actually kind of overfitting, or like I was basically reducing the probability that my ensemble was actually giving to the ferry's gonna be delayed. And I think XGBoost and the random forest were overestimating, whether or not the ferry's gonna be delayed. That's just my conjecture. I'm not totally sure if that's right. And I did not do that much parameter tuning. The validation set was very unreliable, and I didn't really want to push it too hard and start doing crazy parameter tuning on my data. So I found some parameters that worked roughly fine, and I didn't touch them anymore. So I think I had like a random forest. I only tuned depth. I think my random forest were like depth 15, and my XGBoost was like depth 7 or something like that. And I left everything else default. Maybe I could have got better performance with better hyperparameter tuning, but at least in my experience, you end up smashing your head against a wall doing parameter tuning for half or like a quarter of a tenth of a percent of score or whatever. So I didn't, again, I didn't want to overfit the leaderboard like crazy. Instead, I overfit the private leaderboard like a true professional. So and at the bottom, so I basically took 0.4 times my XGBoost predictions plus 0.4 my random forest predictions, then 0.2 times my logistic regression predictions, and that was my ensemble. Yeah, we have a question, and yeah, those are the scores on the bottom, and these scores up here, these are the scores for the individual models, like roughly. So I did get a nice improvement by ensembling my models together, so which was nice, and yeah, we have can we get a mic?
How did you determine the 0.4, 0.4, and 0.2?
Yep.
Is there a method for that?
Nope.
You just random? Okay.
I was like, logistic regression, XGBoost, they're both trees. I trust them.
So just gut.
So yeah, so I'll just put. Okay. I did do it a little bit, but the problem is I wasn't prepared to create this, another validation set where I was going to hyperparameter tune the coefficients of my, ensemble. So I tried a couple values, but I wasn't really going to push it and start fiddling with the numbers because again, I was really concerned I was just going to overfit my leaderboard. But I think if you have a really good validation set, I'm sure there's a much better way to do this. But really, a lot of the problems in this competition, are stemmed from the fact that validation data is a big deal, and like a lot of teams, they did not have. They either had no validation strategies, they had no validation set, or they had one that wasn't very good. Like they just randomly sampled or randomly took a fraction of the data. And I think that was pretty key. Like at the top teams, I think I'd really hope that we all had a reasonably smart validation strategy. Otherwise, you're basically just fitting to noise and stuff, or you're just fitting to nothing, and you're doing data science blind. So a lot of the issues were just due to validation set reliability.
Can I ask you a follow-up on that? So do you know if there is a methodology to or a system for choosing the weights?
I'll poll the crowd on this one. Yeah, so the answer that was given was you can just have a regression that would choose the model weights, and the comment was also that you would need another data set in order to perform this task, or you need another validation set in order to do this. I believe that's stacking. Wouldn't that be considered stacking, or is that, I don't know. No, stacking is something else, never mind. Let's just not get into that, we don't have that much time. There's another question in the back too, can we get a mic out there? Yes. Which is mine blending? Is mine blending or what's mine? Is mine blending or ensembling? Did I get it wrong? Mine's an ensemble?
If you were to choose the weights through regression, this is blending.
Okay. I learned something new. Yeah, so I did an ensemble. So I did something. Okay, so features. Unfortunately, my initial plan was I was actually going to go through the code because I was really concerned that I was not going to have enough time to present. I didn't have enough material. Turns out that's completely wrong. I had lots of material. So I'll just go over the features. So one of the things that I did was, so I used the features that I've outlined up there. I used wind speed data, which was pretty important. One of the big improvements I had was I took the average wind speed of the day. And the thinking was that on days that there's a really severe weather event, like lots and lots of wind, you'd have all these cascading delays. If a bunch of ferries in Tsawwassen were delayed, maybe that would cause delays, elsewhere along BC Ferry's network from people making connections, things like that. And it did lead to a significant improvement. So I added another feature, so the average wind speed of that day to every single sailing. I treated time as a continuous feature instead of categorical. So initially, I just took the hour of departure, and I used that as a feature. But maybe I'm wrong on this, but generally, like tree-based models, if you have lots of like sparse features, like lots of dummy variables that have lots and lots of zeros, it really hurts model performance if you have like 30 columns and only 2 of them are filled out for every particular observation. So one of the things I wanted to do was I wanted to get rid of some of the categorical features. And what I did was I treated time as continuous instead of categorical. And I also noticed some very odd behavior with time. And I just want to show it. So I divided the time, like the timestamp is given in like, 6:45 would be like 18:45 in like 24-hour time. I just divided time. So initially I treated it as a category, as a float, and then I got improvements. And then I just divided the time by 100. I don't know what I was thinking. I was I'll just try it. And I got better performance again. And I have no idea why, because I'm pretty sure that it's not normalizing. It's just it's like normalizing.
It's bringing that variable into a tinier range.
But for decision tree?
Doesn't it? Don't you if you have big numbers, is that one of them?
No, it's invariant to scale.
I imagine even like a logistic regression would be like if you give.
If there's regularization.
Oh, good discussions happening. We have to record them.
Yes.
Okay, so my first comment was that decision trees are invariant to scale. But I'm trying to make sense of this because you said it gave you a boost in your XGBoost model. With the same training and testing split.
Maybe I will run an experiment and I will verify this. Maybe I change 2 things. I'm quite certain on this that when I did change the numbers here, I was getting different results. Actually, we can let's run the experiment right now.
Let's run it.
Okay, so let's just try the random forest. So it's 8-1.
So is there any regularization?
The logistic regression,
I don't think that would-
scikit-learn defaults to L2 regularization for that. Okay, so I just commented out the divide by 100. Let's see if our random forest gives us 0.81.
Well, this is exciting.
It doesn't take for long. It just has to load the data. Just has to load the data. Wait, I think it's already done. Oh yeah, it's done. Oh, we got 0.8. Okay, maybe I was wrong on that. I don't know. I divide by 100 though. that's the solution I submitted. I think maybe it was the regression. Whatever, it's not that important. I think it may have been the regression that got changed. Maybe it wasn't XGBoost. That would make a lot more sense, and maybe that's why my scores got better. But even then, like logistic regression shouldn't be affected by scale. Like if I give like income in millions of dollars or like income in hundreds of thousands of dollars versus incomes in dollars, like that doesn't give me a different model. Whatever. I'm sure I just made a mistake, but whatever. In any case, it doesn't matter. So, okay. So features. So yeah. So I added this feature called like a weather score. So I took the forecast, and I was thinking maybe if it was like raining tomorrow or something, people would be less likely to sail. Like if it was a really rainy, yucky weekend versus a really nice sunny one, people would be less likely to jump on a ferry. Didn't really work out that well, but I included it anyways because it seemed to help. I didn't use the month of the sailing in my data. Again, I was trying to cut down on the number of categorical features. I noticed that I was getting better performance if I just made an indicator for is the month in one of the summer months or is the month in like the off-season months. And that, again, led to a performance increase. But yeah, and I had 13 features in total, and they became 48 after one hot encoding them. Many of those were due to the trip, like the departure. I think there's about 24 just because of that. So that was the majority of it. And if I included all those other like features, like the month and things like that, you ended up with like 65 or something, and you end up with a lot of zeros in your data, which is no good when you're working with trees.
Besides one hot encoding, are there other ways to deal with categorical features that you considered?
So it's model dependent. So XGBoost, you have to one hot encode. I mean, I think if you treat it as an int or something, I think some models, they'll treat it as an ordinal. Am I wrong on that? Some will treat it as an ordinal. Like, for example, light GBM, you can just give it categorical variables. You can say this is a categorical variable. But for XGBoost, you have to one-hot encode it. Or you can treat it as a float. But I don't think XGBoost will take a categorical as like an ordinal or something like that. And for anybody who doesn't know, an ordinal is just a categorical variable that's ordered. So like, if it's in the 1 class versus 2 class versus 3 class, and there's some hierarchy there. But does anybody have a comment on that? Am I wrong on that? Or okay, nobody's saying anything, so I'm right. So
just at a very high level, another way, and this might be considered the same thing as one-hot encoding, but another way to treat categorical variables is to embed them in like a deep learning framework. And so you'll just like represent each of the categories by some length of a vector that the model will learn.
yeah, this was shallow learning for sure. Where, if you came here expecting a bunch of deep learning models, I'm sorry to disappoint you. First, I think generally, maybe it's changing now, I understand, but deep learning models are generally not as awesome as on tabular data. They're kind of on other domains, but I think that's changing now. And I don't think anybody else was busting out the neural nets for this challenge. I think everybody's sticking to your tree-based models, especially with this data. So what didn't work? So I tried light GBM. It doesn't work very well, at least on this data. Because most of the data was really just categorical data, I had a theory that maybe because light GBM can take categorical data, without one-hot encoding, maybe I could give light GBM all my categorical variables, and I could create an awesome model with that because it wouldn't be overwhelmed. But it didn't work very well, and it seemed like it was overfitting like crazy. So I stuck with XGBoost. It also has a depth-first growth policy. So maybe one of you more learned folks can explain to everybody what that means, because I don't really feel like explaining it. It's like it looks like more. It looks more like a single feature, right? Or no, it looks more like there's more interactions. If in a high-depth tree, for example.
It builds the tree down first, as opposed to like levels first. So that just gives it just increases its chance to overfit, I guess.
That's the answer we're sticking with.
That's an option in light GBM, so you don't have to do that. And
I thought light GBM, it was forced depth first, and XGBoost you can choose. XGBoost you can choose.
You might be right on that, actually, because I know XGBoost you have an option between two of them.
Yeah, light GBM you don't, I think, unless they.
That's surprising to me, because I would expect them to. For light GBM handling categorical variables, it would essentially just be doing the same thing as one-hot encoding with XGBoost.
They just save you that pre-processing step. They should just do that for XGBoost as well, so I don't have to one-hot encode everything. Because I didn't mention this, but one of the things when you one-hot encode variables, if a variable doesn't exist in your test set or your validation set when you train on it, you have to go back and add the features back in. So that's what this little bit of code down here does. So I think for my final model, I didn't have any features that never existed. Because when I was working with month, I don't remember, but I added some code there to make sure that if there was a feature in my training data that didn't exist in my test or validation set, it would just add a column of zeros there. Otherwise, the model won't train. But I don't think that ended up mattering at the end of the competition. But when I was using month, or never mind, whatever. So the other thing that didn't work, so I tried other implementations of random forest. So I was using scikit-learn's logistic regression and random forest, and I was just using XGBoost. I tried H2O's random forest implementation. So you can actually, it's not like I think they call them like a distributed random forest or something like that. They're not quite a random forest or something else like slightly different. But one thing you can do is you can build your trees and have your the way the tree is built based on AUC. So I thought maybe if my random forest was building itself based on the metric that I was using to assess it, it would do better. But in this case, it didn't turn out to work very well. It also, you can give it categorical variables and it'll just use them. But apparently it'll just one-hot encode them anyways. And other couple things that didn't work. So I tried binarizing wind speed. So I said, if the wind's greater than 50 kilometers, then it's high wind. Otherwise, no. Didn't work out very well. I tried it once, but I don't think that's too surprising. I created some specific data indicators for known busy days. It didn't work very well. I tried using Twitter data to basically cheat my way to winning the competition. It was a big pain to do it, and I had to go into BC Ferry's Twitter handle and download and scrape all the data. Because unfortunately, if you use the Twitter APIs, they only give you about a week of data, and I needed data from 2018, so I had to copy paste through the timeline and stuff like that. It was awful. And of course, traffic data also didn't work. So I ended up spending a couple hours trying to get Twitter data, and I abandoned it.
Oh, you just couldn't get it?
No, I had the Twitter data. I have the Google Docs with all the Twitter data, but I was like, this is too much work, and I'll do the competition for real. I'll prove to the world I can win. But then I came second. So what time is it? So yeah, okay. So we're ending on time. So I guess retrospective, lessons learned kind of phase. So like all problems, you're not going to be able to feature engineer your way or model your way out of bad data or data. If you don't have the data, then you can't just you can't just beat your data set to death and get it to tell you oh, there was a mechanical delay really early in the day of this particular sailing or something like that. So the reason why there wasn't any team that came out with a model that was almost 100% accurate was because we just didn't have the data. As you saw, traffic data, operational delay data, or traffic delays and operational delays were 90% of the reason why ferry is delayed. And we were really only equipped, aside from using the name of the vessel and the time of day and the sailing, to deal with only weather-related delays. So that's part of the reason why there wasn't any crazy awesome model. So another thing I learned the hard way was you can't just you can't just expect you create some feature in it to actually give you a real performance or performance improvement. You should give each observation some sort of new piece of data. Because if you're a model, you're looking at the one record, and you see the wind speed. Well, you don't know what the wind speed was. For the whole region. Maybe in this particular hour, the wind was really low, but the whole day there's been lots of wind, so now ferries are gonna be really delayed. So when I added a feature for the average wind speed of the day, I ended up getting a performance increase, and that was, I suspect, because of that. And again, building good features is much better than hyper tuning and throwing the biggest, most complicated model at it, which that's not very surprising. And then lastly, basic ensembling is really easy to do. I don't know why it took me so long to actually throw ensemble at something, but it took me 10 minutes to do. I was like, wow, I should have been doing this a long time ago. But yeah, that's the presentation.
Yeah, we have time for a few questions.
So,
And there's another question in the back as well.
sorry. In terms of if BC Ferries wanted to use this to be let's predict how many delays are coming up, or if there's going to be delays in a day or several days from then or a week from then, would it not only be as good as weather data predictions for that week? If you're looking ahead?
Yeah, so glad you brought that up, because it was a little funny to me. It's well, we're predicting whether ferries have been delayed 6 months in advance, but we also have weather data from the actual time where the ferry sailed. Now, I'm sure forecasting is pretty good, and you could forecast it to some extent, but it seemed a little odd to me. I mean, it's within the restrictions of the competition. If this was a real business problem, I'm sure having information that the first sailing of the day on this ferry had a mechanical issue, all the rest of the sailings are going to be delayed. But yeah, it was a.
So there weren't any comments about the usability of what they wanted to get out of the model. It was just a learning.
So-
That's how it was advertised.
Well, so BC Ferries, as far as I can tell, they're not going to be using anything we've made. This was really just I guess a learning competition. I mean, I guess that's with all Kaggle competitions. I don't think they actually really implement any of the solutions ever. But you learn some things about it, and there's a couple other questions as well.
Yeah, what data pre-processing did you do? Did you try removing the sailings which had mechanical failures early on in the day, because that could cause some skew or bias in your data, or did you try removing the cancellations?
So one thing I did do was I looked at all the sailings or all the days that had lots and lots of delays, 40% or greater delays, and because you can cheat a little bit, you can actually look and see, you look on BC Ferry's Twitter, and you can see, oh, there was lots of delays on March 28th, 2016 or something like that. So one thing I did try to do was I tried to remove from my training data days where there was tons and tons of delays, a really abnormally large number of delays. But that ended up hurting model performance quite a bit, so I stopped doing it. I personally don't like removing a lot of my training data, especially if I'm not really sure what the test set looks like. So I wasn't going to start, I want to be very careful. I was going to start carving out my training data, but I did do a lot of pre-processing. This is all my pre-processing code, so it was like, it's quite a bit.
Nice. I was just going to address an earlier question about why we're using weather data to predict the same day. The data was originally collected by someone who had a personal interest in predicting whether there would be delays on the Lionsgate Bridge on their way home from skiing at Whistler. And so they wanted to know if they should eat dinner on the North Shore and wait out the traffic, or if they should take the bridge home. So they would have the weather data from that day available when they're trying to predict the ferry delays. And then it got turned into this Kaggle competition. So that's a little bit of background.
That's a much better answer. Yeah. Everything makes sense now. Yeah, another in the back.
Is there any strategy that you use to deal with the imbalance between the classes?
Nope. I did nothing to deal with class imbalance. I just accepted the fact that it's an imbalance problem. I think generally, like, unless you have like 50-to-1 or 100-to-1 kind of ratio, I don't think it's having a. I think I had it on an earlier slide, but the baseline here is that about 20% of ferries are delayed in our data. There's an imbalance there, but I don't think it's that profound, really. I've had cases, in work and stuff where I've had much more imbalanced classes, and models just kind of chugged along just fine. I tried doing some things where I I sample from the minority class and stuff, but generally I've got really bad results. But I don't know. I don't think that's a universal experience. But in this case, I didn't feel like the data was imbalanced enough for me to start really going hard on, trying to correct it. Because really, if your training data is unbalanced and your test data is imbalanced, then you should kind of leave it like that. Your model should be training on kind of the same distribution as your test data. So I wasn't going to start, messing with the training data. And we were already dealing with issues where we only had particular months in the test data. So I was tackling that different distribution problem.
Oh, just one more question. When you use logistic regression, did you use the parameter, the class weights, to deal with that at all, or no?
No. I just had L2 norm, that's it. I just left it default, and I just, okay, if it gives me a better score, I'm going to keep it, because I have faith in my validation set, because I came up with a reasonably good idea to do it, and I didn't mess around with it at all. I didn't try to correct anything. I don't know if other teams ended up doing that, but I didn't, and I came second, so.
Just one more question.
Yeah.
When you merge the data from the training data and the weather data,
yeah.
There were a lot of missing values. How did you impute the missing values?
So I didn't. So I think I filled. So there's 1,000 cases on 40. There's 1,000 missing wind speed piece of data. Now, first, I have to remind you, I got other wind speed data, so I had fewer missing wind speed data points, but there were only 1,000 missing wind speed data points on 50,000 observations. Initially, I was going to, fill those missing wind speed values a little bit better, but I got really lazy and I just filled them all with like 10 degree or 10 kilometer an hour winds or something. Not a very intelligent way of doing it, but I was. You have to keep in mind I'm in school and stuff as well, so I can't spend 200 years working on this problem. I already spent too long working on it, so I wasn't going to start doing a bunch of imputations. Too much work.
Last question.
Probably something I'd revisit though.
How long did it take you to figure out that wind was the most important factor in the in the delays?
5 minutes after opening the data set, because I was aside from the training data, everything else is useless. I didn't really spend that long thinking about all the other variables. If you just look at why the ferry is delayed, then it's and intuitively wind is probably a factor in whether a ferry gets delayed. So that was not a very satisfactory answer, but I took a good guess, I guess, at what was important and what wasn't. And I should also mention, I know Matt really wants to go to Rogue, but my first solution, I opened up the data set, and like I had my first submission in like 4 hours or something after the competition opened. And the difference between that solution that took me 4 hours to do and this solution, which took me a lot longer, I don't know how long, was like 2% or 2.5% AUC. So it wasn't that much. But but to keep in mind, the difference between those two scores is like second place versus like 30th. So but that's just competition Kaggle for you. But I'll let Matt end the presentation.
Okay, awesome. Let's give him another round of applause.